Hi everyone, Mr. Scott here to talk to you about convection currents. So what I have here is a few different materials that I'm going to use to simulate what could happen in the ocean with convection currents. So I have a beaker full of water, it's warm water, room temperature I guess. I have a chunk of ice from the freezer. I have a pipette with a little bit of food coloring at the bottom there. So what I'm going to do is I'm going to take that ice and I'm going to place it on one side of this beaker. And that's going to simulate like ice or a glacier or just cold water, right? So if that ice is sitting there and I take food coloring and I'm going to dip it right below the ice, what are we going to see that food coloring do? Is it going to uniformly spread out from the ice? Is it going to stay at the top? Is it going to sink to the bottom? Let's think about that. What we know about convection currents or densities or warm and cold water, and see what we think. Okay, so I take the chunk of ice, I set it in the water. That's gonna obviously cool the water around it. So I'm gonna take my pipette and I'm gonna suck up a little bit of food coloring. Now I'm gonna place this by the ice and let's observe what happens. So I'm gonna release that by the ice and I'm gonna move this down here to see that food coloring. Let's see if I can move around a little bit. It is just sunk. It's not really by the ice at all, it's staying near the bottom. And if I can get another side angle here, as you guys get to see everything here, yeah, you can tell that it's really moving to the right quite a bit too. It's going down below the ice and seems to be falling to the right side. Do you see that as it's moving? How can we explain that? Oh, there goes the ice melting a bit. Why would the food coloring go down and around to the right side and still stay in the bottom half? Well, let's discuss and think about it on the next slide and go from there with part 2. Thank you.